Hello, my name is Barisha, and we are talking about universal physical layer number 0 inside of a system on chip JETSON THOR, and to be precise, C2 PCIe controller inside of system of chip THOR. Oh, actually, to be precisely precise, in chip T5000, which is installed somehow on some way on the JETSON THOR model, and which can be, of course, installed on some kind of carrier board, specially adapted for that JETSON THOR module. So a C2 controller is actually part of the chip T5000 made by NVIDIA, and C2 can control 1, 2, and 4 lanes maximum, independence of configuration and what purpose we assign to that C2 controller. And we will see why is times 1, times 2, and times 4 lane, what that exactly means. So we are adapting configuration towards purpose built, for example, on a carrier board and how you want to use it in configuration of the carrier board. So we choose and pick up the configuration inside of system on chip T5000. So PCIe times 2 is default configuration for this C2 controller. So it's like usual configuration for usage is times 2. So it means that it controls 2 lanes, line 4 and line 5. And in standard previous documentation, which need to be updated, lane 5 was reserved, but in this new configurations or new documentation should be changed, that the controlling this lane 4 and 5 is by the C2 controller. So this is wrong. Default setup is that PCIe controller C2 is actually controlling lane 4 and 5 in full setup, and that means that it controls lane 4 RX and TX in sense of possibilities of transmission and receiving, and also lane 5 in possibilities of transmission and receiving in parallel, of course. And also, of course, each one of them, RX and TX, have their own P's and N's, and we will see that later. So they have also specific pins that are going from the system on chip towards a JETSON THOR module. So model pin names are UFI RX and TX4 and RX and TX5. And also, of course, that means that RX have, this is on the system on chip side or T5000 side, they have, let's say, balls on pin or pins which are given here, which are also given here in this row. This is A, B, and this is B row, and we can find these 2 pins for P and N. This is for the receiving side, and also for lane 5 there is a transmission side, which is on the balls or pins K20 and 21. Also, this is names. These are names inside of system on chip T5000, and these are names on the model. So these are continuing from that interconnection in the model towards, for example, carrier board. And also this part is also part of the lane 4, yes, but on the transmission side, and of course it means that it has P and N for the configuring the signals which are going through the PCIe lanes. So standard setup, receiving and transmission for one lane, and that's actually everywhere, either PCIe or NVLink Link. There's always transmission and receive, also Ethernet and so on. And then we have the same story for the lane 5. Also, we have receiving and transmission side, and of course we need to configure signals with the help of positive or plus and neutral or negative or whatever. And also we have assigned balls or pins towards lane 5, which are going from the T5000 system on chip. These are the names of that signals which are going outside the system of chip. And we have also transmission part of the lane 5, and that means that we have two balls, one for neutral or negative and P for positive or plus or whatever. So that completes this story about these two lines. So 8 balls in total for the configuration times 2, and of course for the 4 lanes, if we control 4 lanes, that means that we must include in that configuration lanes 6 and 7, and that means that this number is double, so we have 16. If here we have 8, then if we double the number of lanes for each of the lanes, we need P and N in receive and transmit sides, so it means 16 in total in that case. And of course, we said previously that the rows of the pins are going from A, B, C, D up to L. And here in this example of the carrier board, we can see the configuration of that mini slots for each of these pins to be, let's say, nested here. So this is the example of the one carrier board for the JETSON THOR module, which can be attached on this. And yes, in previous case we said that this is the output from the system on chip, and there is need for that PCIe traces be somehow and somewhere connected with external ports or something, some device one way or another, from which we can, let's say, make interconnection for the PCIe lanes with some device. So in this case, we are seeing that for this carrier board, some ports are given here, which are, let's say, standard or usual ports, and we see here that we have M.2 Key B Slot for Wi-Fi devices and BTs, and that kind of models to be attached to it. So these PCI lanes, which are controlled by the C2 controller, can go or configured inside the system on chip to control this port, and mapped towards this slot. And we can also configure or map PCI lanes which are controlled by the C controller, and make the configuration for the C2 controller to control some lanes which are going towards this M.2 Key B slot. And here the standard configuration which is controlled and can be installed inside of this slot is 4G or LTA and 5G modules. for different kind of communication or 5G communication, for example. Then this, let's say, which is usually controlled by the controlled by can be controlled by the PCIe's C2 controller, but this is E slot, and I think by the number of pins, but I'm not sure how many. I think one lane is going towards M.2 Key E slot, and that two lanes which can be controlled by the C2 controller are going towards this B slot, but we will see that in further talks. So C2 controller works in DM mode, can work in DM or dual mode. So it means that it can be configured as a root port or endpoint or EP or device mode, and what's need to be said that C2 PCI controller can control 5G or LTA network modules, very often mapped towards M.2 Key B slot for connection to 5G cellular modems using ×2 lanes. So we are assuming that we are controlling with the C2 two PCI lanes, which are going towards this slot. In that slot can be attached 5G or LTA network modules. And like we said, they have this purpose of 5G data transfer. 5G data transfer towards this, not from this point or from this network modules which are installed or attached in these slots. So once again, two lanes which are controlled by the C2 controller going towards this slot, and in this slot there can be installed or attached 4G or 5G modules, and you can count that because of the PCIe lane in this case is fifth generation, so PCIe lanes which are controlled by the C controllers are fifth generation. So by the one lane we can have data transfer about 31 point something 5 or something like that gigabits per second per one lane. So two lanes make it double. So, but this is just let's say capability or capacity for data transfer towards these slots. So usually it's two lanes. Also, Wi-Fi or Bluetooth cards can control PCI C2 controller can control Wi-Fi transfer data for the Wi-Fi and Bluetooth cards. So C2 controller can control data transfer for wireless modules over M.2 expansion slots using ×1 lane in this Wi-Fi case. So nothing more special to add here. Usually, probably, maybe I forgot to write this. Usually when you using one lane, you are usually going to the M.2 Ka slot. It's standard, and when we need to use, for example, M.2 K slot, E slot, we usually using a C1 controller because its capabilities are reaching that purpose, and for the using just one lane towards this slot. And so C1 is more appropriate for that role. But also C2 controller in this configuration ×1 can also fit in that role. But more standard role for the C2 controller, because it's using up to 2 lanes in default configuration. Also, it can use up to 4. Is to control 2 lanes which are going towards M.2 Key B slot, and then some more, let's say, complicated or more faster device can be used to send and receive data, and which can be attached on this M.2 Key B slot, and that's the 4G or 5G modules for the I mean, it's not Wi-Fi, but for the wireless communication, but in form of 5G protocols and devices. And for that purpose, and because it's controlling two in standard configuration, it is controlling 2 lanes towards this slot. For that purpose, C2 controller is more appropriate to use. And next chapter can be C3 controller, but you can see also that in maximum configuration it can control also 4 lanes, and somehow maybe it can maximize the data transfer in some case, and in some need independence of what we want and need to do. So also it's not it has purpose to remind ourselves that per 1 lane in PCIe Gen 5 data transfer is about 31.4 or 5 gigabits per second. So if we need to increase that double or quadruple, so it means 4 times 31.4 gigabits per second. So we increase that number. And standard for the C2 controller, PCIe controller, is to make interconnection between to make interconnection with this M.2 Key B slot, and nothing more to add. Here we also can say that C1 is more appropriate for 1 lane and M.2 Key slot, and controller C2 is more appropriate for the 2 lanes which are going towards M.2 Key B slot. One is more appropriate for Wi-Fi, and another is appropriate for the 4G and the 5G models attached to it, and this is for the Wi-Fi modules to be attached to it. So that's all. I hope it was clear, and in the next video we can expect a C3 controller to explain a little bit and have a little bit fun stories about C3 controllers, and in next videos also we will explain U51 and C4 and C5 controllers, which are more or less similar, and we also possibility of C5 controllers I think we mentioned, especially for the QSFP 28 and wired configuration, which is MBGA multi-gigabit Ethernet configuration, but that's a long and another story, of course. Until that, bye bye.